Greetings, grade 11s. Today we are going to be looking at exponential functions. So at grade 10, you looked at the function, the exponential function y is equals to ab to the power of x plus q. The value of a affects the shape of the graph. In which way, you might be asking? If a is greater than 0, the graph is above the exponential, the asymptote, is above the asymptote, and if a is less than 0, the graph is below the asymptote. Remember, what is an asymptote? That line which the line, if you find the value to be undefined, right? The value of b affects also the shape of the graph. If b is greater than 1, the graph is an increasing function. That is if a is greater than 0, and decreasing if a is less than 0. And then 2, if b is between 0 and 1, the graph is a decreasing function if a is greater than 0, and an increasing function if a is less than 0. And then the value of q affects the vertical shift of q, the vertical shift of the graph. So q will be greater than 0. If q is greater than 0, the graph shifts upwards, and if q is less than 0, the graph shifts down. Let's look at some examples. Right, so here we've got we'll first draw the graph of y is equals to 2 to the power of x. You can see it's an increasing function where the asymptote is the x-axis, and when y is equals to 2 to the power of x plus 1, you can see the graph shifts upwards, right? And then when y is equals to negative 2 to the power of x in brackets, you see that the graph is below the asymptote, which is the x-axis, and y is equals to a half, so b is between 0 and 1, your graph is a decreasing function. And if your b is between 0 and 1, you can see again is a decreasing function, and we've reduced the value of q, the graph shifts downwards. And then when our a is less than 0 and our b is between 0 and 1, you can see it's an increasing function. So these are all examples of graphs of the exponential function which you did at grade 10. Now let's move on to something new. So let's look at the way we are going to be looking at the exponential function at grade 11. So we have introduced the parameter p. The value of a and the value of b and q will remain, their effects will remain the same. The only difference now is the value of q. You will see now that the value of p actually is the only new parameter at grade 11, right? So the new parameter at grade 11 is the value of p, and its effect is that it affects the horizontal shift of our graph. So you will see that if p is greater than 0, which means you increase p, the graph will shift to the left. And if you reduce the value of p, the graph shifts to the right. I'll repeat again. If your q is greater than 0, the graph shifts to the left. And then if p is less than 0, the graph shifts to the right. So basically the effects of other parameters like a, b, and q remain the same, right? The only new thing at grade 11 is the parameter p. Okay, so you can take those notes or take a snapshot of that. Now let's look at some examples. So you can take a snapshot of the summary of the effects of a, b, p, and q. Right. So let's do an investigation of the graphs. Right. So we're going to look at the graph y is equals to a, b, x plus p plus q, looking particularly at the parameter p. So you see the functions which we are going to look at here. It's when we have got the parent graph y is equals to 2x, and then we are going to increase p, then we reduce p, and then there we reduce a and see what happens. Okay, and reduce and make a b actually less than between 0 and 1. So let's look at the first scenario. This is the parent graph where the asymptote is the x-axis. So here again we increase p, the asymptote is still the x-axis, but you see our y-intercept is now moved. The original function, which was 0, 1, is moved now to -1, is moved to the left actually. When we reduce p, you see that the point moves to the left. And then when we reflect the graph and then we increase p, you see that the point shifts to the right. So you can see the shifting of the point is indicated in purple there, the side in which it moves. When we increase p, so you can see here it moved in that direction. When we reduce the p here, you can see the graph moved in that direction. And then here we increase the p, so basically it moves in that direction. Okay, moving on. Let's look at the steps to sketch steps to follow when you want to sketch this particular graph. So step 1 is you write down the value of a. Remember, a will tell you if the graph is increasing or when the graph is above the asymptote or below the asymptote. And then step 2, you write down the value of b. Remember, the value of b is dependent on the value of a. So I'm going to write all the scenarios down, which you must know. If a is greater than 0 and b is greater than 0, it's an increasing function. If a is less than 0 and b is greater than 0, it's a decreasing function. If a is greater than 0 and b is less than 0, it's a decreasing function. If a is less than 0 and b is less than 0, it's an increasing function. Right, step 3. You find your x-intercept. Where there's x, when there's y, you put y is equals to 0, and then you solve for x. And that's how you find your x-intercept. To find your y-intercept, you then say you put x is equals to 0 and you solve for y. And then you look for your asymptote. The asymptote is always y is equals to the value of q. So y is always equals to q. That will be your asymptote. Let's look at some examples. That way you will understand what is happening. Right. Example number 1. They say sketch the graph of y is equals to 3 multiplied by 2 to the power of x minus 1. So first of all, you look at the value of a. A is equals to 3, which is greater than 0. So the graph will be above the asymptote. Now, b is 2. Since our a is greater than 0 and our b is greater than 0, so the graph will be an increasing function. Step 3, we find the x-intercept. Where there is y, we put 0 and we solve for x. So you need to know your laws of exponents. In this case, you see that there will be no solution. So step 4, we find the y-intercept. We put x is equals to 0 and we solve for y. In this case, our y will be equals to 3 all over 2, which is 1.5. That is our y-intercept. And then step number 5, we look for our asymptote. Remember, q is equals to 0, so which means y is equals to 0 is the x-axis. So we plot our intercept to get our asymptote, and then the guidance of the value of a and b, we know that our graph is going to be an increasing function like that. Moving on, another example number 2. Sketch the graph y is equals to 3 to the power of x plus 1 plus 9 minus 9, sorry. So we write down the value of a, which is equals to 1, which is greater than 0. The graph will be above the asymptote. B is greater than 0, is greater than 1. So again, the graph is an increasing function. So we find our x-intercept and we find our x-intercept. In this case, it's going to be, our x will be equals to 1. And our y is 0. And then to find our y-intercept, we put x is equals to 0 and we solve for y. So our y will be equals to negative 6. So asymptote is x is 0, y is negative 6. Step number 5, asymptote. Remember, it's y is always equals to. Right, moving on. Right, there we go. Right, so you can see, yes, you first draw your asymptote, then you plot your x and y intercepts, and then you sketch your graph, right, which is an increasing function. Let's look at another example. 3, sketch the graph of y is equals to negative 1 multiplying 3 to the power of x plus 1 plus 9. So again, our a here, you see it's less than 0, which means the graph will be below the asymptote. And then step 2b is greater than 1, so the graph is going to be a decreasing function. Step 3, we find our x-intercept, which in this case we put y is equals to 0, and then we solve for x, which is going to be, our x will be 1 again. So our x in this case is a 1. So the x-intercept is 1 and 0. And then our y-intercept, we put x is equals to 0. And our y will be equals to positive 6. So our y-intercept is 0 and 6. And the asymptote, remember, is y is equals to q, which is y is equals to 9. So we plot our x-intercept, our y-intercept, and our asymptote. Remember, it's a decreasing function, so there it is. Okay, simple like that. Now moving on to a different example now. Let's say you are given the graph, and they say find the equation. You are given the graph with all the asymptotes and all the intercepts. And then they give you find the function or the graph in the form y is equals to b to the power of x plus p plus q. And this is the graph which you are given. Right, there we go. And our asymptote and the intercept, and one more point, we've got the y-intercept. Now, we are going to just use the asymptote to find the value of q. We know that the asymptote is y is equals to negative 3, which means q is negative 3. And then we are given 2 points. So we are going to solve this equation, the other for the value of b. We are going to solve it simultaneously. First of all, we use the point x is equals to 1 and y is equals to 1. We substitute in the value, we simplify it, we make that equation number 1. Then we say at the point x is equals to 0 and y is equals to negative 1. Substitute in the equation, simplify it, make it equation number 2. And then we substitute equation value of b to the power of p in equation 2 into equation number 1. And we solve for b. So we are going to solve for b now. Right, and then it's going to be our b will be equals to 2. Then we substitute the value of b into our equation. Now we are left looking for the value of p. We use the point x is equals to 1 and x is equals to y is equals to 1, and we solve for p. Remember your laws of exponents. When the bases are equal, the exponents are equal. So our p is equals to 1. Therefore, the equation will be y is equals to 2 to the power of x plus 1 minus 3. I hope this was helpful. Just a summary. Remember, this one is summarizing the topic. If you have got any questions, remember to get in touch.